Well, hello, everyone. Welcome to the next episode of CyberJar live streams. And today we are talking about worms. But don't you worry, or maybe you should worry because they are just as disgusting in your CI/CD pipeline as in the real life. So, yeah. And today with me, I have a professional gardener, worm expert, worm warrior, Mohammad-Ali A'râbi. He's like a super special in Docker. He's a Docker captain, author of Docker and Kubernetes security. And if somebody knows something about Docker security, he's your guy. Welcome, Mohammed.
Hello. Thank you. So you probably know about security better than me, but thanks for the nice introduction. Yeah, so I know one or two things about Docker, and now I'm into worms because they're very interesting recently. So
Yeah, that's a very interesting topic because, well, first thing you think about when you think worm, that's something from the animal kingdom, right? Not about software. And that sounds even more disgusting than a Trojan horse or something. But what actually is a worm?
yeah, so if you're thinking about worms, you should maybe think about the very huge worms from the Doom uh,
Yeah.
movies or the books. So the first attack, like the worm attack that happened last year, it was the first wave was called Shai-Hulud. So the worms are basically a piece of nasty software, as you mentioned. They're really nasty, and they would infest your computer. The Basically their goal is to harvest your tokens, and also they would uh, move laterally and then spread. So if you have a GitHub account and the token is somewhere in your computer, they will use it, and then so these different waves have different methods of the harvesting your tokens. But for example, they would create a GitHub repository, a public one, and then put all your tokens there so that everyone can see them and then access to them. There are other ways, like they would reach to a remote server to drop your tokens there. Yeah, and now in the newer versions, so they try to do the server one. If they couldn't, they will fall back to the GitHub thingy. But yeah, so and the funny part about them is that if you have a worm in your computer, they will try to copy themselves into your packages. So if you're a maintainer of a package, they will copy themselves into the package and then publish the package with use of your npm package, like tokens and stuff like that. So they are self-replicating, like malwares, basically.
Wow. But what's the difference between worms and like regular viruses or like malicious package that the developers may install accidentally?
That's similar, but I think that the uh, yeah. So there are different classifications of malware. Worms, I think, are significant in the sense that they self-replicate them and move
Oh,
laterally in your network. So worms are, if we compare them to normal supply chain attacks, uh, then they are a lot more intelligent because they act without a human present. So the worms can act independently of the humans that created them. So that's the nasty part.
that sounds really disgusting.
Yes,
Really, they are awful, awful.
yes.
Right, but I can see that behind you there is a whole team of
Yeah,
people.
there are the worm fighters. Yes, so these are called the Black Forest Commandos. So you can look them up. I have a full wiki on my website with everyone's profile if you want to look them up.
That's cool. That's cool. Will you share your profile and I'll post that in the chat so the viewers can admire. So, friends, we're going to talk about worms. And if you have any questions about them or about Docker security, please don't hesitate to post them in the chat and we will be happy to answer your questions. So, yeah. Right. So, worms, yeah, really sound nasty. So, what must happen for the machine or for the package to become infected? So, what is the first move of the
Yes. Yeah. So uh, basically, they are coming with packages. So in the beginning, so far they have mostly targeted npm ecosystem. So when you install an npm package, uh, if the worm is in the package, then you will get them. So I can maybe share my screen a bit, and
sure?
then
Yeah.
yes. So I'm going
Uh,
to talk about 6 different worms. There
mm.
are more worms now, so that they're just coming. Uh, so Shai-Hulud 1 and 2, the very big one, and then there is mini Shai-Hulud, and the other three on bottom are different like variants of mini Shai-Hulud. I will
Sunstack worm looks very chilly,
yeah.
relaxed.
Yeah, yeah, this one, yeah, because it's called tent stack, right? So the worm is
Yeah.
trying to get a tent from the
Oh
fish.
my. Right. And
Yeah,
Phantom Gip is wow,
it's
like
the
the Phantom
Phantom
of the
of Ra.
Opera, right? Oh
Yeah,
yeah,
exactly.
yeah. Oh my.
Okay, I will
Right.
walk through the worms quickly. So did you probably know about salsa, right?
Well, I do, but maybe somebody from our audience doesn't. So what is salsa? Let's make a quick reminder.
Yes. So
Yeah.
salsa is a framework to harden your build pipeline, basically. So
Mm-hmm.
there are 3 levels of hardening. You can look salsa up in salsa.dev. Salsa without an A, so without the first A. The basically it means so there are 3 levels of you want to uh, have guardrails around your build pipeline, and so that if someone messed around with your pipeline, you can defend against it. So the first level is provenance exit. So what's a provenance? When you're, for example, building your Docker image, you can do something like this. So the first thing is that you want to do a SBOM attestation. So uh, we can talk about SBOM attestations separately, but this one is a provenance attestation, which basically has things like how was this Docker image built? Like when was it? Which build platform was used? And stuff like that. And this is important because you want to have it's like logging your build pipeline, and then if something happens, you can later check it and then see if where the attack was happened, or then check maybe against some other garbage. So salsa is about, so the first level is just you have the provenance. Uh, the other levels are like, so your build platform is isolated, others can't affect it. The images, for example, that you build are signed, stuff like that. And so the hardest level, level 3, it says that the key is not accessible between the steps. So, for example, if you have a token that is used to push to some registry, or to do something, that's the token is only available in that step that is necessary. So these are all because if your CI pipeline is compromised, then you have some guardrails against these things. So this is interesting. We will bear it in mind and then go to worms. So uh, I don't know if you can read this. This is a Persian poem.
Well, not the
Uh,
original.
yeah.
Yeah.
So this is it says the translation says, if the sorrow gathers to overwhelm the hearts of the lovers, the copper is the guy who brings wine and stuff. The copper and I will unite to dismantle its foundations. So this is from a Persian poet in the 14th century, which was called the Lisan al-Gaib. So it was his title.
Uh-huh.
And yeah, you probably know Lisan al-Gaib from here.
Yeah.
So yeah, so
Mhm.
basically, Shai-Hulud was the first form. So it's named after the Dunes book series, or the movies. Shai-Hulud was this worm that was targeting npm packages, and it would infest your laptop or your development environment using pre-install or post-install scripts. So when you create an npm package, there are these parts in your package JSON that says before installing this package, do this, or after. Uh, it would copy itself into one of these things, and then when you install this package, this script would run and then did the necessary stuff. Uh, in yeah, so also in the mini Shai-Hulud, it was using them. Uh, so basically, it's worms. So you see these people are they're fighting the worm.
And does
Uh,
mini Shai sorry, interrupt you. So, is mini Shai-Hulud called that way because it has less damage, or so? Why is it mini Shai-Hulud?
Shai-Hulud is the name of this worm.
Yeah. Hmm.
It but the reason it's called Shai-Hulud is because when your tokens were harvested from your laptop, the worm would create a public repository and named it Shai-Hulud or something like that. So the
Oh.
worm itself called itself Shai-Hulud. Uh, and then they would drop all your tokens there for everyone on the internet to access. Uh, so this is where is it coming from?
Oh.
They yeah. So the attackers were fans of Dune, I guess.
That's cute.
Yeah, that's nice. And yeah, so the how to fight Shai-Hulud. The first two uh, waves of Shai-Hulud 1 and 2, they happened in September and November last year. If you have npm, you can do npm install with ignore scripts. They would silent these post-install or pre-install scripts. They're called lifecycle scripts. So if you do ignore scripts, those scripts won't run. If you have a package that really needs them, you can manually allow it or manually do something with it. Maybe install everything first, and then if this package really needs a post-install script, then run it separately. Uh, so one way to uh, defend yourself against Shai-Hulud 1 or 2 is to ignore the scripts. I'm not super into PNPM, but someone said to me that PNPM ignore the scripts by default, so I'm not sure.
Hmm.
That might be another thing.
Well, I have a suspicion. I'm suspicious that this ignore scripts solution does not work with other worms.
Yeah,
Otherwise, it would be too good to be true.
yeah, exactly. We will get to that part. So this is really interesting. And then yeah, so this year on 29th of April, so it was my birthday.
Oh.
And then the new thing came around, and it was called mini Shai-Hulud. I don't know. So this is a joke because in German, gift means poison. So if
Yeah.
you know,
Yeah.
uh,
That's a
so
nice one.
thank you. So mini Shai-Hulud it's also mini, so it can fit in a small present box. Uh, yeah. So this is interesting because mini Shai-Hulud for the first time targeted AI agents and IDE life cycles. So if you have Claude, Cloud Code, for example, or Gemini CLI on your machine, the mini Shai-Hulud would basically copy some lines into the settings. So there is a setting, for example, in Cloud, whenever you run the agent on the startup, it would run some scripts to prepare your environment.
Mhm.
Uh, if you have an infested computer, when you open Cloud, it would run this Shai-Hulud thingy script. So it would copy itself into Cloud, into Gemini CLI, into VS Code settings, and then this kind of stuff. So this is basically called zero-click vulnerability because you don't have to click it anywhere; it just runs by itself. Uh, yeah, so kind of scary.
Yeah, it is. I mean, zero click. I mean, you don't even have to do anything, right?
Yeah.
You just,
Basically,
uh,
it just pops up.
yeah.
And then, so have you read the Dune books?
Yeah, I did. Like the first two. The first two.
Yeah, yeah, me too. Uh, do you remember how you can kill the Shai-Hulud?
No, not really. No, I don't.
Okay,
Mm.
yeah. So the idea is that Shai-Hulud dies by water. So you put them into a box and pour water on it. So the idea here is that to put the worm in the box. So the water part we will do later, but the putting the worm into a box is the best thing to do basically, because then it won't spread any further. Uh, this is called a sandbox, so it has sand on it, and uh, there is this thing called Docker sandboxes.
Hmm.
New thing, it's free and open source. I'm not sure about the open source, but it's free at least. And so it's a standalone thing. If you don't have Docker, you can still do it. It's creating a micro VM in your machine and then puts the AI agent in it.
Mm-hmm.
So if the AI agent is affected with worms, it cannot access your tokens and then do nasty stuff with it.
So it's kind of like a safe box,
Yeah.
right? And the
Yes.
agent cannot leave the sandbox even if it tries to, right?
Yes. So
Cool.
you can use the sandbox to run agents, but also you can do it for like normal development. So if you can run a sandbox with Ubuntu on it and then do
Mhm.
other stuff. Doesn't necessarily need to be a cloud or something. Uh, but yeah, so the important part is that it's a micro VM, so you have more separation than a normal Docker container, because it's easier to get out of a Docker container than from a micro VM. Uh, you still, so if you have an agent, you still have to uh, mount your directory, your project directory into it. So the agent has some access to your computer, but at least it doesn't have access to your tokens and stuff.
Cool.
Yeah. So that's one part, and then good. So we're getting closer. So there is this 10 stack poisoning. So 10 stack is, if I have you heard of 10 stack?
Well, that's another worm, right? The Tanstack worm.
Yeah. So 10 stack is uh basically a series of packages, and they were compromised by, so the worm basically, uh if I remember correctly, uh one of the maintainers had a phishing attack, and they got access to these maintainers tokens,
Uh-huh.
uh npm tokens, and then they uh I no, I think it wasn't npm tokens. They had access to his GitHub account, so they published some orphan git commits. So because it's an orphan git commit, it's not very visible because it's not attached to anything else, but it uh, triggered the CI pipeline. And with the CI pipeline, they could poison the build cache. And when the normal pipeline was running, the cache was poisoned. So
Hmm.
the cache that was used to build the packages had the worm in it. And it's interesting because it rendered salsa level 3 insufficient, because the packages that were published had salsa level 3 and with signature and everything, but they were infested.
And
So
this is absolutely scary, because Salsa level 3 is like the
the
strongest
latest
security you can
thing.
have in place, right? And
Yes,
it's
yes,
just right in the beginning, it's poisoned and it's useless.
yes,
God.
because the weak point was not defendable with salsa. So this is interesting, and how the worm is advancing more than the defenses are. So
Yeah.
yeah.
Really
So
scary. Yeah, really
so
scary.
basically you have a shotgun. The shotgun, the worm comes out of the shotgun and then out of the pistol, and then yeah. So you yeah. This is basically what we are dealing
Oh my.
with. Yes. So what's significant about Miasma? I don't remember exactly. It was significant because it compromised 32 packages. in the
Red
Red
Hat,
Hat
right?
Red
Mm-hmm.
Hat Cloud Services. Yes,
Mm-hmm.
uh, and there is Miasma Wave 2, which is called Phantom GIP. So this is very interesting because then it will bypass the ignore scripts thing that I
Mm.
mentioned. So
Mm-hmm.
there is this like feature of npm that if you have some C code, for example, in your packages that you want to compile when you install the packages, then that part is bypassed by ignore scripts because that's not a post or pre-install in a script that's keep binding if and then that's what it's called. So it basically runs a script with that, and you can't uh,
Mm-hmm.
prevent it from running. So Miasma Wave 2, it happened in June, in the beginning of June, and then this was what happened. Uh, this is still, I would say, this is if you okay. So we can if you have any points to add.
Uh,
Otherwise, I have a checklist of things we can do to
yeah,
cover.
well, my question was right about things we can do. So we have different kinds of worms, right?
Yes.
They act differently, and are the ways to fight them going to be different, or is there a universal solution to fight them all off?
Yes. So I would say different things. Yeah. Let's take a look. So still, you should do also level 3. So although some worms bypass it, uh, that's important. Pin your versions to certain like versions, because when these worms are published, so they come with packages, right? And you don't want like uh, these forms, the packages that have form in it, be installed automatically. So if you have things like give me the latest version, then you have no if you want to install something, you have to make sure that you would really want to install it. So if you're pinning your dependencies, then it's the first step. The second step is to have a cooldown period. Some people are not a big fan of it, but I think all of these worms that I mentioned so far could have been caught if we had a 5 days cooldown period. So usually, if a package is coming with a CVE or a worm, uh, people will notify within the first 5 days.
Mm-hmm.
And if you wait 5 days and then install, you already know if the package is uh,
Mm-hmm.
bad or not. So that's one thing we can do, so that we don't have 0 days. We already know that this package is bad. Uh, that's the cooldown. That's one of the things we can do as a consumer of packages. Uh, Trusting AI. So AI can also do, because we are giving AI the control of our computers basically, and AI have access to everything, and uh, sometimes that's not a good thing. So first thing is to put it into a sandbox. At least it won't have access to all the tokens that it doesn't need, and so Docker Sandboxes also has a uh, secret manager, and if they want to have access to a token, they have to ask for it, and then so there is a proxy layer there at least. Uh, and short-lived keys. So if you're signing things, or if you're getting some tokens to access something, then it's better to have short-lived keys, so that if the key is then uh, accessed by someone, then it's not that dangerous. If you have a key that lives for 5 minutes, then doesn't matter if it's exposed to the public.
Mm-hmm.
And so disabling a script is still a good thing to do. And yeah, so also maybe the last thing is to have an incident playbook,
Mm-hmm.
because so don't wait for the attack to happen
Yeah.
until yeah.
Yeah, until it happens. Yeah.
Yes.
Yeah. So you mentioned we know that as worms can bypass salsa 3, and they can also infest the S bomb so that the S bomb that we produce can actually have the false information, right? And the
Yes.
information about the malicious packages. But still, we do need to implement salsa and S bombs and image signing and hardened images, right? It's not that something that we neglect doing.
Exactly.
Right?
Yes. Yes.
But what do these things still protect us from? So why do we still need salsa, S bombs, hardened images?
Yes. Okay. So there is this other thing that we want to protect ourselves from. That is CVE. So these worms are, uh, I would say, a very specific kind of uh, vulnerability that targets your uh, targets the developer's environment. In a sense, uh, we have all sorts of CVEs that are coming with the packages, and those are so. Although these ones are very advanced, uh, there is a less possibility, or uh, it happens less often that you're attacked by a worm than having a normal CV. So normal CVs are like, this package has this issue, and then everyone knows about it. And if a package has an issue and everyone knows about it, you probably should protect yourself against it, because you know about it and the attacker knows about it, and the attacker knows how to exploit it. And
Mm.
if you end up having this package in your production code, then everyone knows how to use the how to exploit these vulnerabilities. And SBOM protects you by listing all the packages that you have in your code and in your Docker image, and then you can check the packages again against the publicly available list of all the CVEs, and then check if you have some vulnerabilities in your code that you can fix later. I think by law you are obliged to get rid of your CVEs within a time frame. So you really want to have some visibility into it. Uh, so if you have some SLA and stuff, uh, and SBOM is one part. You want to have signatures, because this was a very specific incident that the signature wasn't sufficient, but it's still necessary, I would say. So most of the time, signature means that this thing is trusted. If you don't have a signature on it, then it's not trusted at all, and it's a lot easier to uh, for the attacker to change it, and then you won't know that it was changed. Uh, and yeah, so that's basically, so that's the normal CVE part. And then yeah, so and you mentioned the hardened images. Most of the CVEs come from your base image, so that you probably want to have some base images that have less CVEs. So basically, things like Docker hardened images that have almost zero CVEs, or uh, chain guard ones, or and you want to have in your production container, you want to have a Docker image that has no root access, no shell, and no package manager. So in case the attacker could get inside it, they can't do anything with it. So
Yeah, so there are several vendors actually of hardened images, friends. If you have never heard about this concept, I encourage you to read more about hardened images. I think we can call it a new de facto security standard for containers,
yes.
right? So, and yeah, there are several vendors. So there are Docker hardened images, there are Bellsoft hardened images, there are ChainGuard hardened images. So you can look at different providers and choose the images that fit your use case best, right? With the Leslie, with the licensing, with the variety of images, right? So you just choose, and then, yeah, that's the solid, very solid foundation for
Yes.
your container workloads, right? The hardened images, yeah.
So the Bells of Harden, I met Pasha last week, actually,
Ah,
in
in
Berlin.
in Berlin,
Yes.
on the meetup, they had this.
Yes.
Yeah.
So there
Mhm.
was VR developers, and then
Oh yeah.
one day
Mhm.
before that, we had the pre VR developers meetup. I
Oh,
was
okay.
one of the
Mhm.
organizers, and Pasha was there. And yeah, so we briefly talked about those soft hardened images. Uh, are they only for the Java, or how does it
No,
work?
no, no. We have the variety for different languages. So we have hardened images for Python as well, for Go, for Node.js, and for C and C++, and also the bare hardened Linux. Right. So if you want to use it as is, right. So there is the portfolio is bigger than Java, although we started with Java, yeah. So
Okay, I
primarily it
see.
was on Java, yeah.
Okay, I see.
Right. Yeah. Right. There's one question that still bugs me. Why is the NPM ecosystem so attractive to these worms? I mean,
Yeah.
what?
So
Yeah. Mhm.
now there is the latest attack. I just checked it before coming here. There is, I think it's called Hades, if I'm not wrong,
Oh,
and they're attacking npm packages. So what?
again, I mean, it's always about the NPM packages. I mean, what's the deal?
No, sorry, Python pages. The last one is Python. So pip, but yeah. So also funny story. There is a thing called Maven PM.
Oh.
So it's a fusion of Maven and npm, and these worms, I think, got into the Java ecosystem through Maven PM as well. Uh,
Mm,
but I think npm is more attractive because there are more consumers of it.
mm,
So all the front end code is npm plus some part of the backend code. But if you target, I don't know, Maven or Python, there are less people using it because it's only backend or yeah. And so npm is huge, and it might also be that npm has less guardrails around it. So I'm not very much into how different package managers work. So, but yeah, so that might be one part.
So basically, Java ecosystems are safe if they don't use this Maven PM thingy.
Thinking, yeah, so it's safer, but there has been not yet that I know of an active attack on Java package managers. But some funny thing is that this mini Shai-Hulud attack, this worm, the, the the team that created the worm published its code online. So
Mm,
anyone can use this code and attack anyone they want. So
that is somebody like a Joker. Some people just want to see the world burn.
exactly, yes, yes.
Yeah. That's a dangerous place to live in.
Yes, yes, exactly. And even if we don't talk about like very sophisticated worms, currently, uh, I would say attacks are more sophisticated because then you have AI, and then before that, if you wanted to attack, you had to really have a lot of knowledge about how to attack people, and then now you can just ask your AI to help you out.
Yeah. So, do you think that these worms were also created with the help of AI?
Probably, yeah, I don't have access to the code that they
Yeah,
published, but yeah,
sure.
so I want to look into it because now it's very interesting.
It is, but it's a very sophisticated attack, right? And I'm just suspicious that it might have used AI to somehow devise this code. Uh, how do you see, if we speak in more like broader terms, how do you see the cybersecurity evolving in the future? Because right now it's a race, right, between hackers using AI and cybersecurity experts using AI, right?
Yeah,
And nobody knows who's winning this race. How it
yes,
will all evolve? What do you think?
yeah. So one part is that now this new model that was published and then unpublished quickly after, uh, I- it
Yeah.
was basically because they ran this model on some code bases and it could find a lot of holes in the code. And so someone made that very interesting example. If you have watched Terminator 2, uh, the one the robot that was attacking was the T-1000, and
Mm-hmm.
they sent a T-800 to defend against it. So the T800 was the older technology, so we still can use older technology to defend against the newer technology. So that's better than not defending that. And then there are things like, uh, for example, the AI agent can be. It's interesting. So there has been some attacks that the AI agent's settings is changed, but with characters that are not visible to human eyes. So there are these zero width characters that you can't see, and they would uh, infest the cloud code settings, for example, and you can't do anything about it because you can't see it, but you can run it against another agent and then tell it, yeah, please take my setting and see if you can catch anything there. So you can still use like technology that's available to you to do something about it. But yeah, so this is great. And back in the days, so there was another statistics that I saw, but I have to find the source. The time to respond to attacks is decreasing, and then it's probably
Mhm.
now. So when last year this React 2 show happened, React 2 show, I don't know if you
Yeah.
remember.
Yeah.
Yeah, so the React
Mhm.
was found to have a security issue that would allow people from the internet to run anything. If you have a React code running on your servers, people who had the React application on the browser could run a script on your servers from the browser. Uh, when this was disclosed publicly, the time to React was basically 2 days. I, I had a friend of mine said it whoever, so he's running a hosting uh,
Mhm.
company, and he said that the project that uh, spent more than 3 days to patch their software, all of them were uh, attacked. So all of them had crypto miners running on their servers. So it's really scary now because you have to act super quickly, and then if you have an large organization, that's impossible.
Yeah, so the time to patch really is faster, but sometimes the problem is that the teams just don't rebuild their images and maybe don't monitor the situation because, for example, Log4j, I mean, that was a bomb virtually, right? Something that is super dangerous. And yet, there are still, statistically, there are still services that run the affected vulnerable Log4j versions of the package. I mean, that's
From fibers, I think last year there was a statistics that like 30% of the
yeah,
all of the
yeah.
installed versions are the infected one. Like, and this is from 5 years ago or 6 years ago. So yeah,
Yeah, 5. Yeah, I guess 5. Yeah, right. I remember that. And it's just totally insane. I mean, the patches come out, but then nobody introduces the patch, and then security is just as fast as the slowest team, right?
yeah, true.
That's yeah. But what
Yeah,
do you think? Can we somehow alleviate the situation? Maybe we can use AI to monitor for patches in our base images and to open PRs and what's not.
yeah.
Something.
But yeah, so I think you need to have a baseline security in place. Like, I think first step would be telling your AI agent to build some security jobs into my repository, like create a job that checks my Docker images for vulnerabilities, and whenever I create a PR, publish a comment in the PR that says, okay, this image now has this amount of CVEs, maybe five critical ones, two medium, things like that, so that people have some visibility in it. If it's somewhere in some dashboard, no one cares. Uh, and then so this is maybe the baseline security to have these, and also it's important, I would say, to check the Docker images with everything in it, not just package JSON or just the I made POM file that you have with your uh, application things on it, but to have everything, because if you when you everyone now basically ships Docker images, right?
Mm-hmm.
Uh, if you have a vulnerability that comes from the OS package, that's also a vulnerability you want to fix. It's not only the vulnerabilities from the Python packages or npm packages, and yeah, so having a baseline uh, security is important, and then this AI bot can come around and patch the uh, packages, and then you at least after the package is patched, you have an visibility into if did this package patch increase my CVEs or decreases it, something like that. Because you might end up with a package that has worm on it. Yeah, which is also hard to catch because you wouldn't know it in the beginning.
Yeah. Well, that was really cool. I mean, scary stories about the worms, really. I am paranoid now. So maybe some of our viewers as well. Can they somehow check whether they have a worm in their pipeline or not right now? Like, do something?
Good question. I Yes, I think these things are really hard to track. I would run an AI agent on it. So the AI agents can check the internet for latest context, and then you can tell them to check my repo, check my setup, check my agent settings, check my browser, the ID settings, stuff like that. Check if I have something next. Uh, and yeah, so also these things are probably published as CVEs later, and then you can check the packages.
Mm-hmm. Mm-hmm. Right. I found one of your articles called Beyond Salsa. I will post this link to the chat and then to the description of this video. That's where you describe these worms as well, right? So
Yes.
maybe for the viewers also to look into. So in the end, Mohammed, what are three well, imagine we have a team with like starting from ground zero with the Docker security.
Mhm.
What are three most important things they need to introduce in the first place?
Okay, that's interesting. Uh, good. So I would say it starts with. So first of all, I would say if you have a Docker image, especially if you have a multi-stage Docker image, you should create SBOM attestations. Maybe I can bring up my other
Sure.
slides. Okay, how can I unsure and then share again?
Uh-huh.
Uh, good.
Okay.
Yes, so the first part would be uh, having uh, SBOM attestation generated, which is not also super hard, as you saw earlier. I will share again.
Mm-hmm.
So
Okay.
give me my entire screen.
Okay.
So
Mm-hmm.
did it? Yes.
Yeah,
So
cool. Mm-hmm.
if you have a Docker image and when you're building it, so you probably want to have the SBOM attestation uh, generated for it, because at the SBOM attestation, if you don't have SBOM attestation and a scanner like anything like Trivi wants to check your image against uh, the publicly announced CVEs, it has to scan through the files and then try to figure out what's installed there.
Mm-hmm.
With the SBOM attestation, it doesn't have to do that. The list of all the packages is already there. If you have a multi-stage build like this, so this is a very interesting example because it's a C code. The first stage
Mm-hmm.
copies the C code into the container and then builds it.
Uh-huh.
And the final output of the compile is a binary file called hello, right? And then
Mm-hmm.
in the last stage, it just copies this binary into the image, and the image is from the scratch. So it has nothing in it except for this one binary file. In this case, if you check the image with 3V or anything else, it would say that there is no package in it. But there were some packages used to build this library, right? To build this
Mm-hmm.
thing, and you want to include them in your uh, SBOM attestation, and you can do it by adding this argument here,
Hmm.
which
Mm-hmm.
tells build-kit to include packages from this stage into your SBOM attestation. And then if you do SBOM attestation in your Docker build, then all these packages are available to all these scanners that are not possible to have them otherwise. So this is probably the first stage. First, it's an easy fix, right? You
Yeah.
just add one flag there, and then this argument here, and then you probably want to have visibility into the CVEs of
Mm-hmm.
your own repo at least. So you might want to have a CI check that checks the CVEs, publishes
Mm-hmm.
some report in the PR comment, and you might also want to have a rule like if I have a critical CVE, it fails so that you can't merge the pull request. You want to really fix the critical CVE before going live. Yeah.
Mm-hmm.
So
Mm-hmm.
these are so, and if you have a, like GitHub Actions pipeline, it's really easy. So you just have to add these two things. So SBOM true for SBOM attestation and provenance. This is the one that we discussed before.
Mm-hmm.
So
Mm-hmm.
it's also level one is having provenance.
Yeah. Mm-hmm.
So these are two things, and then what's the third thing? So that's
Mm-hmm.
what do you think? What should be the third thing to do? Ah,
Uh, yeah.
you
Huh?
want to, yeah. So the third thing I would say, so selfie, harden images. Yes.
Yes,
Yeah.
yes, exactly. Yeah. My man. Yeah.
Yes. So hardened images. So this is about Docker hardened images. As you said, please check all the different
Yeah,
ones.
different providers. Yeah. So we're
Yeah.
speaking about as a concept, right? So hardened
Yes.
images. Mm-hmm.
So in this case, Node 24. This one comes with, if I'm not wrong, 400 CVEs. I
Mm-hmm.
checked it yesterday. So
Wow.
the numbers here are not accurate. So this one has 400 CVEs in it.
Mm-hmm.
If
Mm-hmm.
you use Docker hardened images, uh, so there are two variants, right? So there is dev variant, which has root, package manager, shell. This is for your earlier stages when you want to install
Mm-hmm.
things and then build things. And if you have a production stage, then you want to use this one, which has no shell, no package manager, and no root. So if the React to shell happens, then the attacker can't do anything with it.
Mm-hmm.
Yeah.
Mm-hmm.
So three
Yeah.
things: SBOM attestations, like 3V or some CVE
Mm-hmm.
check, and then hardened images. Yeah.
Yeah. And actually, they are all are not quite that not that complicated to introduce, right? So
Yeah.
actually, so
One day
friends.
work probably.
Yeah, 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 exactly. And then you get already a more solid foundation that you can build on, right? That you
Yeah.
can then introduce a proper CVE management workflow, increase the salsa to level 3. But then still, you need first this very solid foundation, right? And that's what you
Exactly.
get with SBOMs, with provenance data, scanners, and Docker well, hardened images. Yeah.
Yes. I
Yeah.
have an interesting story. So at one company where I worked, we had a message coming from the hosting company that said you have this critical CVE on your server, so the
Mm-hmm.
running server, and we had no clue where it's coming from.
Mm-hmm.
It took us a month to figure out where this CVE is coming from, and then Uh,
Wow.
yeah, so if it was something like Drake to show, then that's not nice. Uh,
Yeah.
if you have like repo level visibility, at least if I don't know, the CTO asks who is this CV coming from, at least the team knows. And then the next level is to have an integrated application that checks everything and then puts them into a place that you have a visibility over the whole organization. But that's the next level. So I just
Yeah, exactly. So visibility and a clean foundation. Yeah,
yeah,
that's what we need in the very beginning. Well, thank you so much, Mohammed. That was super interesting.
thank you.
Again, scary stories, but we know that they have the happy ending, right? If we do security properly. Thank you, everyone who watched. This stream is going to be available as a recording on YouTube, so you can rewatch parts of it or the whole of that. And I will post Mohammed's socials and articles in the description so that you can contact him if you have any further questions about Docker security or the worms, right? And I want to read some cool articles. Well, thank you, everybody. Thank you, Mohammed. This
Thank you.
was
And please comment your favorite worm in the comments.
because it's so cute. I mean, it's mini Shai-Hulud. I don't know. Looks very cute and not that terrifying.
Yes, so
But
the
that's not the
looks are
truth.
deceiving.
Yeah, it's not the truth, of course. Yeah. So, right. Thank you, everybody. Thank you, Mohammed.
Thank you.
And until next time. Bye bye, everyone.
Bye.
Bye.